We thank you for the gift of this lesson we are going to join, Lord. We ask you that you grant us the spirit of knowledge, wisdom, understanding, and remembrance, so that we can also prosper in our forthcoming exam. We pray all this through Christ our Lord. Amen.
Amen. Thank you so much for the word of prayer, Vicky, and good. Yes, and good afternoon, everyone. Thank you so much for joining. Today, we are going to look at what we call the test for an inverse functions. Last time, we were looking at functions, and today, we are going to concentrate mainly on how do we look out for the inverse of a function. And when we talk about an inverse of a function, what do we mean? So that is the thing we are going to look out for in our session today. We are going to first learn how do we find out that this function has an inverse. And from finding out that the function has an inverse, we shall go on and learn how do we get an inverse for a given function. So that's what we are going to look at in our lesson today. So by the end of this session, you must be able to determine whether the function you have has an inverse. However, we are going to concentrate on the graphical approach. So we are going to use the graphical approach to find out whether actually what we are dealing with can be or has an inverse function. Okay, someone can read for us the first part, and people, I will ask you to raise up and you give us some examples. Okay. Vicky.
There have been times in which you did something and then undone. It gives some examples. Have you
Thank you,
ever
Vicky.
worked? Okay.
Yeah. So can we, if you have an example whereby you have done something and then after you had to undo it, what are some of those things? I want you to look at your life. What are some of those things you feel you have done and then after you had to make another new decision? Vicky, do you have an example you want to share with us?
Like anything you've ever done, then you undo it.
Yes, anything.
Okay. So I can take an example. I'm just trying. Let me take
Hmm.
an example of making
Yeah. Vic, I lost
something
you.
using your hands, like you're making something, then maybe you make a mistake. You
Oh, sorry. Vic, I'm going to call you again. Yes, Sharif. Sharif.
Good afternoon, sir.
Yes, good afternoon.
Good afternoon, sir.
Yes, good afternoon, Sharif.
The example I have two examples.
Okay.
One,
Hmm.
one, you can freeze water
Hmm.
and then you melt it. Then
Okay,
second,
thank
you
you.
can be drawing with a
Hmm.
with a, with a pencil,
Hmm.
and then after making a mistake, you can use your rubber and then clean.
Okay, okay, thank you. That is correct. Thank you, Sharif. Yes, Martha.
I think something that you can do and undo
Hmm.
is like, for example, powering in and powering out. Like you
Okay.
power something,
Uh-huh.
yes, in maybe like you got juice or water from a
Hmm.
jug, then you
Mm-hmm.
put it in your cup, then maybe you are
Hmm.
tired of it, so you put it back in.
Okay, okay, okay. Okay, thank you everyone. Now, those are some of the few examples people have, but I know there are quite others that we may have. So, the topic we are looking at when we talk about inverse Inverse means undoing something, undoing, reversing what you had earlier done. And that's what we are going to look out. So I want you to, I've given you an example here. Someone can read for us. You can raise up the hand and you read for us. Okay. Okay. Elena?
Thank you, sir. So it is, think of inverse functions as reversing something you have done. For example, you are writing a sentence. Producing a sentence is similar to the output or result of the function, and then you change your mind and decide you do not need your last sentence. You would just do Control plus Z in some editor to cancel this sentence. The Control plus Z function will take your last sentence as an input and return your original text as the output.
Wow. Thank you. Thank you. So, members, that is what we call an inverse. It is undoing something. And I know you have seen some of these things happen in life. You do something, and then after you change your mind, and then out of the blue, you find yourself that you have erased what you had done before. Now, what do we look at when it comes to functions? Now, when it comes to functions, we have two things. I know in your senior 2, you looked at what we call a domain and what we call a range. Now, when we are talking about inverse means that you interchange. What has been your domain becomes your range. What has been your range becomes your domain. Now, your domain is the set of X values. Your domain, those are your inputs. What have you put in? Then your range is what we call the output, what you get at the end of the day. However, I want to let you know that for not all things we do in life can be reversed. There are some things you do, there are some mistakes you make in life whereby you cannot undo them. You do it once, it is there and there, it cannot go away. However, there are some things we can reverse, but not everything can be reversed in real life. But mathematically, we can make many of those things, many of those functions reverse. In the chat, if people can give us some of those things in real life, you can't reverse. Once it happens, it has happened. It will never change. I know you know some of those things. There are things you cannot undo. And that's why you need to be very careful before you make any decision in life. Ask yourself, will I be able to undo it? People have said age, death, growth, getting pregnant, breaking a glass. Yes. Speaking someone. Yes. Yes. Decomposition. Now, all those things you are mentioning. Yes. Oh my God. Someone, Jeremiah. Okay. Okay. Very good. Yes. Some of those things you cannot undo them. So that's why you need to be very careful. Whenever you are making a decision in life, make sure you ask yourself, will I able to undo it? Even here, having an opportunity for learning. Sometimes, like even time doesn't come back. You cannot say, oh, I'll go back. Time just keeps on moving. Then when we talk about the range are your output. Those are the Y values. Now, when we are talking about inverse, an inverse means that interchange. What has been your X becomes your Y. What has been your Y becomes your X. You just interchange the two. So what has been your X becomes your Y. What has been your Y becomes your X. That's what you call an inverse of a function. Take an example. If I have this coordinate 2, 4, and this has been my function. This is my input, this is out. If I want to get the inverse, I'll have this 4 come here, I'll have the 2 come here. So my inverse will instead be 4 and then the 2. However, not everything we find, not every function you are going to find, it will have an inverse. There are those that we may not have. So what is an inverse of a function? How do we write an inverse? Now I know if you look at some past papers, more so in the old curriculum, you may have found things of this nature. Whenever you write f, then you put a power of -1. This means f inverse. That's the meaning. So whenever you find it somewhere in the book, that is what stands for the inverse of a function. So it depends on the function. Sometimes it can be h, so they write it like this. But whenever you find a power of -1, it will be standing for an inverse of a function. Now, in your own words, can someone raise up and tell us what can we write about an inverse of a function? What have you so far understood by an inverse of a function? What are you going to write in your book? Because now I want you to make some notes about inverse of a function. Okay, start with Martha.
I think what I would start with writing when it comes to the inverse of a function is it is a way of making something go back to its original, what it once was. Like, for example, if you had maybe 2 mangoes, then you made them, you maybe went through a process and made them 5, is if it is possible to try and reverse them and take them back to being originally only 2.
Okay, thank you. That is okay, Martha. So members, let's make some small notes on what we have understood by inverse. Yes, Sharif.
What I've understood,
Mm.
inverse of a function is all about interchanging
Mm.
when given things, taking back to the things to the original state, like it's like a reflection.
Okay. Okay, perfect. It is like a reflection. Very good. Thank you, Sharif. Make those notes. Make your own notes. Yes, Pena.
Teacher, could you please pardon? I've just joined. I don't know what's happening.
Oh, Spena, we are talking about inverse of a function. So people are telling us what they have understood by an inverse of a function. So listen in such that you can pick something as well.
Okay, teacher.
Okay. Jeremiah?
What I've understood from an inverse of a function is that it reverses what the function was doing. Like, for example, if the function was giving us how many kilograms of flour are needed to make a certain number of chapatis, this time it will give us how many chapatis will be made by a certain amount of flour. Yeah.
Okay. Thank you. Waswa?
Teacher, for me, I think inverse is a reversible change that enables you to obtain the original substance.
Okay, perfect. Then lastly, Okilia. Chris Okilia. Okay.
I think
Mm-hmm.
an inverse of a function is returning something from something to original state. Like when you have made many things, then you return to original state.
Okay. Okay.
Yeah, I think
Emily, you are the
an
last.
inverse of a function
Mm-hmm.
is the action of reversing.
Okay. The action of reversing something. Okay, blessing. Blessing. Be the last.
I think an inverse, it's like a vice versa, something like that.
Okay. Like a vice versa. Okay. So members, Spena, let me hope you have picked. Let me hope you have picked. Okay. So that's what we are looking at. That's what we are looking at. Okay. Lastly, Becky.
An inverse of a function is like reversing a process. For example, let's take an example of the steps of matter. You put like water in a fridge, then it becomes solid in solid form. Then you reverse. If you want to reverse it, you go and start heating it. Then it goes back to original to its original form, like water again. That's all I've understood about inverse of a function.
Okay, thank you. Thank you so much. So we are going to continue. Timothy, we shall give you a chance. Timothy.
Teacher,
Timothy? Yes.
I want to say that inverse is the opposite of something.
Opposite of something. Okay, very good. Very good. Techno? Okay, so we are going to proceed. Now, how do we test for an inverse of a function? Now, in order for us to test whether that function we have has an inverse, we use what we call an horizontal. Is what we call an horizontal line testing. What do we mean by an horizontal line testing? Horizontal means that you draw a horizontal line. After drawing your horizontal line, you check out if the line you have drawn cuts that function at more than one point, then it means that function does not have an inverse. An example, now, who discovered this? The gentleman who discovered this approach is this gentleman you are seeing on my screen called Wafabujan. Yes, it's the one who discovered things concerning the functions. I'm going to do one, and then members, the rest are going to be done by you. What do? We have said we use an horizontal line testing. So what do? I'll have my line, I get my line. This is my line. I will draw my line like this, horizontally. Now, what you see in red is what you call the function. This is what you call your function that has been drawn. This is the function. Now, you check. If that line you have drawn is cutting your curve at more than one point, then it means it has no function. Take an example. You are noticing it is cutting here. This is one point. It is cutting here. This is another point. Therefore, when you have this function of this nature, we shall say that this function has no inverse. So here we conclude that it has no inverse. Members, is that fine? Let me know through the chat. Has everyone understood that concept of how we test that the function has an inverse or no? Is it fine to everyone? People are saying I do another one. Okay, I'm going to do one more. Another one, I'm going to come. We have said you test. It is just a matter of you drawing an horizontal line. As long as that line cuts your curve at more than one point, then it means that it has no inverse. If it cuts at one point, then it has an inverse. Take an example. I can draw a line here. I draw a line here. I draw a line here. I draw a line here. This is one line. I'm just showing you. Now, even for this one, even if I had drawn another line, you notice that there were 2 points where your curve could cut. Now, what about for this one? You notice that the only point where this line cuts the curve, it is at this point, at one point, at one point, at one point, at one point, and at one point. Now, for such a function, since it has only one point where the horizontal line cuts it, then we shall say that this one has an inverse. Because for any corresponding value of y, there is only one input. So here, it means that there is one value of x that corresponds to the y. In other words, for this one, you notice that when you have 2 and when you have -2, this side we have negatives, we have like negatives. So what are you noticing? You are noticing that here, when you have 2, you get a value. When you have -2, you get a value. In other words, we cannot have more than 2 inputs and we get the same answer. So one input should equal to one output. We should have a 1 onto 1. Members, are you getting that? Are you getting that? Is that okay? For an inverse, let me first pick Becky. Is it a question, Becky? Okay. Tekno, is it a question? Okay, yes. So, yes, Tekno?
Master,
Yes.
pardon.
What I've said, What I'm saying, when you are testing whether something has an inverse, you just draw a horizontal line like this. Now, the line you have drawn, when you look at our function is this curve, the red one you are seeing is what you call a function here. Now, if you find out that that horizontal line you have drawn is cutting at more than 2 points, then it means that that line has that curve has no inverse. Are you getting it?
Yes.
So when you check here, you notice that they are cutting it here and here. So it has no inverse. A curve, a line, a function that has a line, a curve, an inverse, it only cuts at 1 point.
Right.
Have you understood?
Yes.
Okay. Now, other members, can you tell me whether C and D has an inverse? Place your answers in the chat. Say inverse, no inverse. Okay. Yes, 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 Martha.
I think C has an inverse.
Why, Martha?
Why? Because you can connect lines, you can connect dots, points from the other side of C to this
Martha,
one.
can you write on my screen? Try
I
to write on
think
my screen and you draw that line and you show us. Uh, uh. So, Martha, remember,
yes.
let me first clean. Remember, we have said we use a horizontal line. So I want you to draw a horizontal line. It's the one that you conclude using.
So
Others, don't write on the screen. Let's first leave her and we see. Good.
I think even one can be drawn.
It is okay. It's okay. Good. Martha, now what are you concluding on? Basing on
That
your
C
observation.
has an
Why?
because it is possible to draw parallel lines and they meet the curve.
Okay. Yeah, okay. So members, that's how you test. That's how you test. So for you you draw the line, you draw. As long as there's an horizontal line. The moment you find out that that line is cutting at just 1 point, then it means that it has an inverse. Members, lastly, part D. What is your conclusion? I'm looking through the chat. From Jeremiah says that D has no inverse. D has no inverse. Okay. A.
Teacher, mine is a question.
Yes.
Can the horizontal line be on the x-axis itself?
On the x-axis, yes.
Okay, thank you.
Okay. Yes. Now, for this particular one, I know you may be looking at this AA. Now, this one here, just because it is a curve, but it is only meeting at this point. There is not any other point, but it can as well be on the horizontal, on the x-axis. Okay. Spinner.
Teacher, why don't you use a vertical line, only horizontal?
Why don't we use a vertical line? Okay. Now, the tests, a vertical line works under other conditions. However, according to we are going to look at it. We are going to look at it when we reach the point of algebraic inverse. I will respond back to it when we reach the point of algebraic inverse about that thing of vertical testing.
I'd like to answer D.
Okay. D?
D has has no inverse because the curve or the arc is cutting through more than one point.
Thank you. Thank you.
Welcome, sir.
Okay. Members, let me hope that concept is now at hand. So whenever you have a graph, never rush to find an inverse before you test whether it has or whether it does not. Now, someone has asked, why do we use a vertical line testing? Sorry, why do we use an horizontal, not a vertical? Allow me to respond now to that point. Now, for anything to qualify to be a function, one of the condition is it must be a one-to-one function or one-to-one mapping. When you were in senior 2, you looked at what you call one-to-one. Now, why do we use the horizontal? When you look at our x line, our x point, x thing lies along the horizontal axis. Now, being that it is lying along the horizontal axis, we know very well that for something to be one-to-one, we must have one input to correspond to one output. And therefore, when you check here, you note that at this point, allow me to just use this. You note that for this function, when you have your x equals to 2, your output is 3. You check here that when your x is equal to -2, your output is 3. So in case you come here and you are trying to draw your domain and arrange, here you are going to have your x value. You are going to have 2, you are going to have -2. But your output is going to be 3. And therefore, when you try to match, you are going to get something like this. And this one results into what you call many to one. And many to one doesn't qualify to be a what? A function. And therefore, the reason why we want to use the horizontal line testing is that it determines whether a function is one to one. That's why we don't use a vertical, because the moment you use a vertical, you may not know which values correspond to each output. Let me hope I have answered you. Yes,
Teacher,
but
many to one? Why is a many to one not a function?
okay, now that one we are going to come on it. We are going to come on it, but that's what you covered in senior 2. In other words, you cannot have very many inputs giving you the same output. That is the thing. That you cannot have very many, let me say, you cannot tell me that you have different products that can give you sugar. In other words, we are saying that sugar canes are the only things that can give you sugar, not you having different products that can give you the sugar cane. Okay. Okay. So we are going to proceed. We are going to proceed. But now that one you need to go back because you learned about functions in senior 2. Okay. So hope this one came out very well. Allow me to give you an exercise now. You can first draw all these lines in your book. And then I want you to answer through the chat what A, what B, what C, and what D have. Do they have inverses? They don't have. Mm. So I think in case you want to use for the vertical line testing, again, maybe let me keep on adding. The vertical line testing, for it helps in identifying functions only. But if you are testing for the inverse, then we use what we call an horizontal line testing. If you are identifying whether something is a function, you use the vertical line testing. If you are identifying that something has no inverse, we use the horizontal line testing. Mm. Mm. So the vertical tells you whether something has a function. Horizontal tells you whether you can invert something. That's the meaning, or that's the difference between those two lines. Okay. This is Pena. Spena?
Yes, teacher.
Yes, I'm seeing your hand up. Maybe you can answer part A.
A has no inverse
A has no inverse. Why?
because the arc is, if you draw a horizontal, the arc is passing through more than one point.
Okay, thank you. Gemma.
Good afternoon, sir.
Yes, good afternoon.
Uh, I had a question,
Hmm.
and my question was, if you're going
Hmm.
with a horizontal line,
Hmm.
do you have to draw randomly, or it has to pass through the numbers?
Oh, you can draw randomly as long as it is passing through your function. As long as it is
Oh,
passing through your function. For you can draw it anywhere, as long as it passes through your function.
okay. Thank you, sir.
Okay. Uh, Aria.
Good afternoon, sir.
Good afternoon.
Maybe I can answer B.
Okay.
Okay, B has an inverse
Okay.
because
What? Mm-hmm.
when you draw a horizontal line through the function,
Mm.
it only meets at one point.
Okay. Thank you, Aria. That's correct. Timothy.
Yeah, part C
That's
has an inverse
okay. Why?
because when you draw a horizontal line to the function, it only crosses one point of the function.
Okay. Thank you, Timothy. That's correct. Lastly, AA.
D has no inverse
Mm-hmm.
because when you draw a horizontal line across the graph, it meets the curve at more than one point.
Okay. Thank you. Thank you, AA, and thank you, everyone. So, members, I am taking an assumption that this concept is okay. Is okay to everyone. Now, we go to the graphical. What about us getting them ourselves? How can we graph them ourselves? That's what we can look at. Now, we are going to look at how do we graph these functions. And now I want to bring it to your attention that when we talk about an inverse is a reflection. However, which kind of reflection is a reflection in the line y is equal to x? A line y is equal to x, how does it look like? So when we talk about an inverse, is that when I have my line like this, an inverse is a reflection in this nature, whereby when you have something here, it will appear here. When you have something here, it appears here. So this is what we call y is equal to x. I understand you looked at reflection in senior one. So when we talk about an inverse is the reflection of the function in the line y is equal to x. And if you remember your reflection in the line y is equal to x, you remember you could just interchange. In case you are reflecting something, you could just interchange those digits. You make your y to become your x. Why don't we look at an example? Now, the first one, they are asking us that draw the function fx is equal to 2x plus 1 on the graph. Now, we know very well when we are going to graph at this level, they don't give you the values of x and y. You must create them yourselves. So what am I going to do? I'm going to create a simple table. In our simple table, we have x. And this f of x, members, let it never confuse you, is the same as the y. So here we are going to put f of x. Now our x here, always it is a good practice. Have some negatives, have some positives. So I'll come here and I say, let me start from -2, -1, 0, 1, and then the 2. It is up to you to start from wherever you want and to end where you want. Because here, they have not restricted you the values of x your function can take on. Now, the first one, we put in -2. So we say that when x is equal to -2, you come in your function, you say f of x is equal to 2x plus 1. Now, where there is x is where we put the -2. So we say f of -2 will equal to 2 times -2 plus 1, which will give us -4 plus 1, which gives us -3. Hope that is okay. Can I have another person to take us through the next one? Sharif, take us through the when x is equal to -1.
When x equals -1, f of x equals 2x plus 1. Then we substitute equals 2 times -1. 2 times -1 plus 1. -2 equals -2 plus 1 equals -1.
Okay, thank you. Jeremiah?
Yes. So when x is equal to 0.
When x is equal to 0.
F of x is equals to 2x plus 1.
Okay.
F of 0 is equals to 2 times 0 plus 1, which will give us 1.
Okay, thank you, Jeremiah. Aria?
Okay. If x is 1, then f of x will be equal to 2x plus 1. Then f of 1 will be equal to 2 times 1 plus 1. The answer will be 3.
Okay, thank you. Martha?
If x is going to be maybe 4, I'll have 2x times is 4 plus 1 is equal to 8 plus 1, which is 9.
Okay, thank you, thank you. Okay, so we are going to substitute. So here I have -3, I have -1, I have 1, I have 3, I have 5. And always do not forget, it's a good practice to write out your coordinates. I'm going to come here and I write -2, -3, -1, -1, 0, 1, 1, 3, and then 2, 5. Then the one for Martha was 4 and 9. Okay, I don't know that people want to answer all their questions. Aine, is it a question? Okay. Okay.
Excuse me, Master.
Yes.
I'm somehow confused, Master. When you were teaching us that testing using the horizontal line, yeah? Those curves. Now you said that they are functions. How do you know that it is a function? Because since you started teaching us the function, composite function, you never taught us about those curves. Now, how do you know that this curve is a function? Now this is just a curve.
Now, okay. I'm going to respond. Remind me after this plotting. I'm going to explain. Okay. So members, allow me to come here on our graph. allow me to come here on our graph. So this is my graph. I'm going to plot. 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 So on my graph, I'm going to plot. I'm going to plot. Let me use this. -2 and -3 is a point here. -1 is a point here. 0 and 1 is a point here. 1 and 3 is a point here. And then 2 and 5 is a point. Oh, it's a point here. Now, after plotting, I'm going to join. I'm going to join. I'm going to join my starting point to the end point. So I'll join like that. Now, that is my line for that function. Remember, our function was 2x plus 1. So our function is 2x plus 1. So here, you can even label it that your function is equal to 2x plus 1. Now, members, how do you know that it is actually a function? Now, for us to test whether it is a function, we use what we call a vertical line testing. Now, for anything to be a function, it must intersect your graph at most once. At most once. Is that fine? It must intersect at most once. In other words, it shouldn't be beyond 2 points when you use a vertical line testing. Is that fine? Hey, that is what we call a function. That when you draw your vertical line, it must touch your curve at only 1 point, not more than that. So I'm going to give you an example. Let me use this. I use this yellow. I don't know the yellow will be seen. Green. So when I use here, I'm going to just draw. And then for you, you check out. And then you'll tell me whether it is okay, whether it is a function or not. So when I draw my vertical line here on these curves we have got, does it meet at only 1 point? This is my line. Allow me to first mute people. That is one line. I've drawn this. So you notice that this line here can only meet our curve at only this point. Can meet the line here, only here. And therefore we shall say that this is a function. So this is a function. And if something is a function, then you check out whether you can obtain its inverse. Another example, allow me to give you another example. Take an example. If we had our graph and we had something like this. What you do, you ask yourself, is it a function? What you do, you come members, you draw your vertical line testing. Now, as long as what you have drawn meets at more than 1 point, then this one is not a function. So this one is not a function. Hope members have got the difference. Let me know through the chat. Has everyone understood that? How to test whether something is a function? Understood. Very good. Okay. Let me give you one and you tell me whether it is a function or no. I have this. We have said if you are testing a function, you use a vertical line testing. I repeat, when you are testing for a function, you use a vertical line testing. Members, I have this. Tell me, is this a function, not a function? Put in the chat, function, not a function. People are saying it's not a function. Yes, because once you draw your vertical line like this, it is meeting here, it is meeting here. Once you draw here, it is meeting here and it is meeting here. So we shall conclude that this one is not a function. So like whenever you are inspecting a graph to see whether it is a function, we use a vertical line testing. Yes, so that one, you need to be aware of it and how to use it. However, at one point I will also let you know that we can as well at one point turn these functions to them to be functions, you can as well turn them to be function by restricting their domain. Members, I have another one here. Is it a function? Not. Is it a function? Not. People are saying it's not a function. Very good. Very good. Then the last one. The last one. The last one. The last one is here. The last one is here. Is it a function? Okay. 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 Good. 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 Okay. So now we are going to continue. Now, if members, we are going to look out for the inverse of this function we have drawn. What do? To get the inverse, we interchange. What has been your y becomes your x. So this one goes up, this one comes down. That's what we call an inverse. What has been your y becomes your x. That means that here we are going to have -3, -2. We shall have -1, -1. We shall have 1 and 0. We shall have 3 and 1. And we are going to have our 5 and 2. This is what we call f inverse of x. Whenever we are finding the inverse of this is our function f of x. If we are finding the inverse, we interchange. Your x becomes your y. Your y becomes your x. So I'm going to plot now these ones. Do you remember this is still your x, this is your f of x, but now this one is inverse. So we plot -3 and -2. -3 is here, -2 is here. -1, -1 is here. 1 and 0 is a point here. 3 and 1 is a point here. 5 and 2, this is 5 and 2 is here. Then after, I'll join. So I'll join like this, like that. And this is what we call the inverse of our function. So this is what we call f inverse of x. So when you look at this f inverse of x, you can tell that this is a reflection. Because if I had drawn a reflection line for this particular line, remember, even sometimes you are required to draw the reflection line. So in case I'm drawing the reflection line is y is equal to x. So you have your x, you have your y. In case this is 1, this is 1. This is 2, this is 2. 3, and this is 3. So your reflection line looks like here, 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 and here. So let me see how I can come up with that reflection line. So this is your reflection line here. That's how it looks like. Yes, so that is how, so this is a reflection line. And those who remember how to reflect, you remember when you are at this point, you bisect, you can stand here, bisect, you stand at this point, bisect, come here, bisect, and then draw. And then measure off this distance and this distance here. Okay. Now, I'm only going to, if you are not having a question, I'm going to ask you to first have your hand down. And then I first have people who may have some questions raise up their hand. In case you have a question, you can raise. If you don't have, first have your hand down, and then we respond to those people with a question. Okay. Genevieve. Okay. Genevieve is not unmuting. Spena.
Teacher, you've at first you were using horizontal line. Now you're using vertical. I'm confused. When do you use vertical and do you use horizontal?
I
Because
repeat,
in the
Spena.
examples you use, yes, teacher.
I said horizontal, you use it to test whether you have an inverse. Is that okay?
Yes.
Vertical, you use it to test whether it is a function.
Okay, teacher, good.
Yeah. Okay. Nusla?
Yes. Good afternoon, teacher.
Yes, good afternoon. Members, you can be drawing your line in the graph. Yes, go on.
Sir, for me, my question, it's on the first when we are using horizontal line test. There is a certain, I think it was part D of the first example that you've done. And at some point, I saw when it has an inverse, then at another point when it does not have. So at that point, what gives us the answer?
At one point, you saw it had an inverse at another point.
Yes.
No, like you need now to know. Like what I think you are saying is there is a difference between a function and inverse, whether if it is a function, whether it has an inverse. So take an example. When I have this function here, this one is not a function. This is not a function.
Yes.
I see. But if I'm trying to find whether it has an inverse, then I can as well test and see whether it has an inverse as long as I do this. In other words, can you be able to undo it?
Yes, teacher.
Hey, so it is possible. I think that's what you saw. Hope it is okay.
Yes.
Okay.
Thank you, sir.
Thank
Okay.
you, sir.
Nusla? No, I think Nusla we have finished.
Yes.
Okay. Frederick?
Yeah, I have a question that are we supposed to get a curved line or we have to get only straight lines?
We can also get curves. We can as well get curves. Okay. Hey, I will show you a curve. Melvin?
Arriba.
Okay. Melvin, I've lost you. Mercedes?
Mama.
Good afternoon, sir.
Good afternoon.
I would like to ask where this reflection line came from.
Like I
I
told
don't
that,
understand how it came about.
like I said, like an inverse is a reflection of your function. So I included, and always whenever you're finding an inverse is a reflection along this line. Y is equal to X. Always. So what I was demonstrating to you is that when you draw here a line, you can surely see that it is just a reflection of this particular line. Our green line is a reflection of this line here. I don't know that you have got the point yet.
Yeah, thank you.
Okay. Okay. I think Kiki.
Sir.
Sirikashina. Sirikaye.
Okay. No, so let me first remove you and mute you. Kiki.
Oh, sir, I wanted to request that I came in the lesson late. So I wanted to know how you get a function and then an inverse here. I didn't understand how you know it's a function or an inverse.
We say that for something to be a function, you just draw a vertical line in the curve. As if you find that it is meeting at 2 points, then that one is not a function. When it comes to inverse, we use a horizontal line. The moment you draw your horizontal line and it is only meeting at 1 point, then it has an inverse.
Thank you.
Okay. I think the rest, allow me that we continue such that we can have yes. Now, like someone was asking, can we have curves? The answer is yes. We can do have curves because not all the times that we are going to have to have that. So allow me to first pause this. Now, what about when we have the curves? Now, we can have a curve like you see this curve and they want us to find the inverse of this function. Now, if they want to find the inverse of this function, members, what do you do? One thing you need to remember is that To find an inverse is a reflection along the line y is equal to x. And there are some things by this time you need to know. When I have y is equal to x, y is equal to x means that this is my x value, this is my y. It means that for the values of x, let them be anything. Let me say it can be -1, it can be 0, it can be 1, it can be 2. And when you come and substitute where there is x, because you have y is equal to x, it means you have y is equal to -1. So this is going to be -1, 0, 1, and 2. The moment you substitute where there is x. And therefore, after you plot these points, such that you draw your reflection line. Whenever you are finding an inverse, show your reflection line. So I'm going to come here and I show my line. That my line is going to be -1, -1, which is a point here. It's going to be 0, 0, a point here. 1, 1, 2, 2, and 3, 3. That is my reflection line. And therefore, I'm going to draw my reflection line in that format. So that red line you are seeing is a reflection line. Members, this is a reflection line. But how do we get the inverse? Because this curve you are seeing is the function that we want to find its inverse. What do? What you do, look at that curve you have and get some points. I want members in the chat to look at this curve, and read for me some points you have seen those people have plotted. The ones that you can read, put them in the chat. Any point you see that you can read, put it in the chat. As long as for you can read it there. On the curve, though not on my line. Someone has given, AA has given us 1 and 1. 1 and 1. On the curve, it should be on the curve. Someone has given us 0 and 0. Good. So far we have 2, 1 and 1, 2 and 2. 2 and 2 and 2 is not on the curve. It must be on this curve here they have drawn. 2 and 4. 2 and 4. Very good. 4 and 4. No, 4 and 4 is off. 2 and 4. Very good. So members, you can notice that there is this point on the curve, there is this point on the curve, and there is this point that you can comfortably read. Now, to obtain its inverse, what do? We have said any inverse is a reflection. Come here. What you do, interchange. This one comes this side, this one comes this side. So its inverse will be 1, 1. So meaning that for this one, you plot 1 and 1. 1 and 1 is here. 0 and 0, still the inverse remains. 0 and 0 is here. For this one, you interchange. This one comes this side, this one comes this side. So you have 4 and 2. So here, I'll have my 4. My 4 is not fitting, but I know my 2 is going to be here. I'm just so I can add just let me add just let me add. When you look here, no, let me not use this color. Let me not use this color. Let me here. When you check out, allow me to extrapolate it a bit and then have something here like this. So you can notice that when I extend my graph, you can notice that 4 is somewhere here and 2 is here. So I'm going to plot that 2. So 2 is here. Now what I do, I plot. But if it is a curve, each sketch will also be a curve. So I make sure I go through those points. So members, I'll go like this, like that. So that's going to be its inverse. Yeah, so that's how you sketch the inverse and you come up with that inverse. Members, let me know through the chat. Are we together? Are we on the same page? Are we leaving some people behind? People are saying yes. Okay, Chizito has a question. Let me pick Chizito. Yes, Chizito, ask.
Yeah, so teacher, my question is mainly, it's not about the curves there, but let's say I had a line y is equal to 0. Does that line qualify to be a function? And also, how would you show it against like the reflection?
Now, y is equal to 0, we cannot say that it is a function because y is equal to 0 is this x-axis horizontal line, right?
Yeah.
So it shows you that it does not perform anything. That's the meaning.
All right.
A function means that there is something you do. But if you are equal to 0, it means that there is nothing you are performing. Is that fine? Okay. Okay. Now, some of you are saying, how are these curves related even to math? Now, some of you, even where you are seated in your houses, you are seeing those, like when you look at your shade, you look at those curves like coming like this. Those are mathematical curves. Hey, when you are doing structural engineering, when you reach that point, some of you are going to go into engineering, you must come up with these curves using mathematics. Hey, they don't, and when you find that the curve didn't come out well, it is an indicator that someone didn't do it well mathematically. Some of you have seen corners, you have seen roundabouts. Those are mathematical concepts. You have seen even your doors where that are curved. All those are mathematical curves. Some of you are currently using a mouse for your laptops. That one is a mathematical curve. Yes, so they are applied almost everywhere. Even I don't know whether you know why your when you look at your profile pictures, be it on WhatsApp, do you know why they use curves? Why they use those circles? There is a mathematical reasoning behind it. Yes. Okay. So yeah. So Roy, what's the Roy?
Good afternoon, sir.
Yes. Good afternoon.
Unfortunately, this is my first lesson, and my inquiry is like, what topic are we in? This part is all good and all, yeah, but I just wanted to read some back notes. Like, we in physics or math? Then the topic exact, to be more exact.
Okay. This is math, and we are dealing with functions. This is our fourth lesson. Okay. So allow me to give you one more. So it looks like that. It looks like that. I have another one here. I want people to try out roughly. You try out in your books and see what you come up with. Imagine this is our curve. I want you to try out and see how your curve will look like, how your reflection will look like, as I respond to some items, to some people. Let me hope, Loy, it is clear.
Yes, thank you, sir. It's actually clear right now.
Yeah. But in case you want any other lessons we have had, you go to YouTube, you'll be able to find them there.
Okay.
Okay. Melvin,
So I did not understand the other first part.
which part?
The other one where you first reflected.
Like, be a bit specific. Which part is it that you need support?
Okay, so when we were beginning these things, that first number we dealt with.
Like, for the first number, did you understand how we came up with the points we plotted?
No.
Like, remember we had our function f of x equals to 2x plus 1. Are you meaning that number?
Yes.
Yes. Did you understand how we came up with f of 1 and we came and said 2 times 1 plus 1 and we said this is equal to 3?
No.
Okay, do you know how to fill in? Let me say you have y is equal to 2x plus 1. When x is equal to 0, which answer do you get for your y if you feed in this function?
0.
Remember, feed in well. Where there is x, you put 0.
It's 1.
It's 1. So that means it will be 0 and 1, your coordinate. What about when you have
Yes.
x is equal to 2? What do you have?
X is equal to 2. 5.
5. Now that is what you do. I've told you that this F means is the same as the Y. It means just an output. So for whatever values of X you have, just feed them in the formula. Then at the end of the day, whatever coordinate you have obtained, it's what you are going to plot. I don't know that we're on the same page now.
Yes, you're on the same page.
Now, after getting all those coordinates, you just interchange them. In case you got 0, 1, its inverse is the interchange 1 and 0. In case you had 2 and 4, you interchange them 4 and 2. So you plot the first ones you obtain and then the inverse you have obtained as well.
Okay, thank you, sir.
Okay. Joel?
Excuse me, sir.
Yes.
Like, I'm questioning on how to draw the curves.
How to?
Like how to draw the curves.
Did you look at quadratic curves in senior 3 term 3?
Yeah.
Yes, so the way you were drawing them is the same way we do them here. But here I've told that when it comes to an inverse, look at the curve you have. Can you identify for me one point you see on this curve that you can read?
2, 1.
2, 1. That's 1.
Yeah.
What could be its inverse?
1, 2.
1, 2. You plot that point. Identify another point.
1, 0.
1, 0. What could be its inverse?
0, 1.
0, 1. So you do like that. Now, at the end of the day, you know that, like I've told you, it is the reflection. When you put a boy in front of a mirror, you'll get a boy. When you put a jerrycan, you get a jerrycan. So if here you had a curve, also you must know that you will get a curve. But like you look at it like the way you look at the mirror. In case you look yourself into the mirror, like the image will appear to look at you. So that's the same thing you have to come up with. But in case it is a curve, you have to come up with a curve. In case it is a phone, you come up with a phone.
Okay, so thank you.
So now make sure you come up with a curve similar to this one as well. Okay. Fatuma, members, let me hope we are coming up with a curve. I'm going to display the curve and we see. Yes, Fatuma.
Teacher, for me, I'm confused on how to plot the reflection and where are you getting those points?
Which points?
Those coordinates you are plotting to get the reflection.
Like, are you seeing this curve here? That's where we are getting them. For you look at this curve, the coordinates you can read easily are the ones you take on. So for you look at it and say which point can I read off? Let me say you can read off comfortably this point here. Then you say this point here. What is the coordinate? What is this point?
It is 4 2
and 2.
4.
So what is its inverse?
2 4.
2 4. Then if for you come you plot 2 4 like that. Is it okay?
Yes.
Then you continue getting other points you can read off and interchange.
1 and 0.
1 and 0, and then you plot it. Yes, for you, as long as the point you can read off easily, then plot it.
So that is the reflection.
Yes, what you get is the reflection of that line, of this curve, is the inverse. For you, when you place yourself, like here, look at it like in the way you put yourself in a mirror. If this is the person in the mirror, you are going to see yourself this side. This is the mirror. You see yourself this side. I don't know that you're getting it. Here, look at it the way you look yourself into the mirror. If you place yourself here, you will see yourself here.
Yes.
Okay.
So
Then
that
I
is the
think
reflection. Then the inverse.
that is the inverse. That is the inverse. Inverse, we have said, is a reflection. What we are talking about maybe is the reflection line. The reflection line is always y is equal to x. In other words, we always put our mirror in this format, in the vertical format. And I've told you this is a standard thing always. That line is zero, is y is equal to x. So that one is automatic, will always be there. What
Yeah.
you just need to know it, that line will always be there and it will look like that. That's what you call the reflection line. It's like the mirror. This is your mirror. Y is equal to x. The image you get is what you call the inverse.
Okay, thank you. I've understood.
Okay. Yes, Sharif. Members, have you finished?
Master, my concern was that the application of these curves, but you have tried to explain it a little bit behind there. Then I was just inquiring that now, Master, how they set these questions when you have to draw that curve, because I know this is our last lesson. Try to elaborate a bit there, Master. Kindly,
Okay.
thank you.
Okay. Now, Sharif, this topic is still on. It's still on. We are still building the foundation. Yeah, we are still building the foundation. And now we cannot bring in a bit of scenario at this point, minus you knowing even how to do them algebraically. Yeah. But we shall get there. We shall get there. Okay. Conrad, but we shall get there.
Good afternoon, sir.
Good afternoon.
Teacher, like we are using a line of reflection, but if I decide to find the inverse without using reflection, like the line of reflection, is it okay?
But okay, mathematically it would be better when you include it there. But though we know it that it is always under that reflection.
Okay. And then, like today, our lessons are ending today. We are not having any more lessons.
Who said so, Conrad?
Okay, because on the timetable it was stating we are stopping last week.
Okay, the lessons are still on the whole of this week.
Like I was meaning math.
Oh, math. We still have some time because now I'm saying we still have about 30 plus minutes. So there is a lot we are still working on.
Okay, sir.
Okay. 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 Where is JJ? Okay. Okay. I think the rest, I think I've answered many of your questions. So members, you are going to notice that when this is -0 and -4, so it is -4 and 0. So if you have come up with your curve in a format like that, then that's what we call an inverse. So let me show you my clear graph. Yeah, if your curve looks like that, members, you have done a great job. So that's how your curve looks like. In case you got your answer like that, then it means that you have understood how we do curves on using the graphs. So that's what we do when it comes to graphical approach. So in case you find a graph and they have asked you to find its inverse, that's how you can do it. So allow me that for the rest, I don't know whether Spener, what could be the question?
Teacher, the line of the reflection, teacher, it's just the points between the the reflected arc and the no, the main arc.
Yeah, this is the object and this is the image. Now, in between is what we call the mirror. The way you did a reflection, like this is like the mirror. This is you as a person, This is you in front of the mirror. What you see is the image. So what you see inside the mirror is the inverse.
Teacher, is it a must to put the reflection arc there?
To put the line, yeah, it is okay.
Yes.
It does well. It does well. It shows you are understanding what you are doing.
Okay, sir.
Okay. Kiki. Kiki. Okay.
I wanted to ask that how do they set them in scenario questions?
Okay. I'm going to come to that. I'm going to come to that. Roy.
Okay.
Oh, Mr. Steven. Is it Steven? Steven? I was just inquiring about this line again. This straight line. What's it again in detail?
What? Come again?
Oh.
I was just inquiring what that line is again.
This is a mirror line.
The
This is the mirror. I've told that, like, when this is yourself. When you stand in front of the mirror, you see yourself inside. Now, when we are talking about inverse, what we see inside is what we call the inverse. What we use to see ourselves is what we call the mirror. And this one is always y is equal to x. And then this is the object. So this is a mirror line. The one we use to reflect that you cannot reflect anything unless you have a mirror.
Now I'm shining.
Okay. Okay. So you're going to allow me that I cross this discussion at this point. Yes, I'm going